So good morning, everyone, and welcome to the second webinar of the VitiGEOSS project. This webinar is part of the European Green Week, and I'm Andrea Nicodemo from the Barcelona Supercomputing Center. And today we will discuss the implementation of data analytics for a sustainable and climate resilient agriculture 4.0. Throughout the webinar, you can use the questions and answers box to ask questions to the speakers, and we will have a look at the agenda now. Rosa, if you can move to the agenda, please. So first we will have a welcome and overview of the VitiGEOSS project. Then we'll discuss the integration of data sources for greater food sustainability. And the next talk will be about advanced sub-seasonal to seasonal climate forecast for adaptation. Then a talk on data-driven models for disease prediction. Next, towards optimized and sustainable business management. And then a sneak peek into the VitiGEOSS services. And we will end with an interactive session and questions and answers. So now I would like to give the floor to Rosa Araujo, the project manager and the project coordinator, who will give us an overview of the VitiGEOSS project. Please, Rosa, go ahead.
Hello. Good morning, everyone. I'm Rosa Araujo, project manager at the EURECAT Technology Center in Spain for more than 12 years now, and coordinator of the VitiGEOSS project. First of all, thank you very much to the Green Week organizers for allowing us to explain what we are doing in the VitiGEOSS project, because events like the Green Week help a lot to share initiatives for a collective action and cooperation. Now, it has been a while now that terms as climate change, biodiversity loss, pollution, and waste are around and have become a challenge for all of us. And our main objective in this webinar is to showcase the use of data analytics in solutions for agriculture to be more sustainable, reducing the usage of raw materials, water, pesticides, and chemical fertilizers, and in consequence, moving towards a healthier food product and greener agriculture practices for the environment. And today I'm going to talk about VitiGEOSS. What is VitiGEOSS? This is a European Horizon 2020 project funded under the call SC516 2019 for the development of commercial activities and services through the use of Copernicus and GEOSS data. This is Earth observation systems, meaning information collected over the planet, atmospheric, terrestrial, or oceanic. What we intend is to develop innovative tools for the wine sector with Earth observation services and in-field sensors to help to a more sustainable agriculture. The project duration is 42 months. It started in September 2020 and will end in February 2024. We are currently in month 22 of implementation, which means that we have finished the requirements collection phase and we are advancing in the development of the services and their validation. The consortium is composed of 9 partners representing 4 European countries, which are Spain, Portugal, Italy, and the Netherlands. The 9 partners in the consortium have the necessary experience and operational capacity to implement the challenges of the project and represent its complete value chain. As technical partners, we are EURECAT, which apart from being the coordinator, has extensive experience in the application of artificial intelligence for process optimization, and in VitiGEOSS is responsible for the disease management service, resource management, and sustainability. Barcelona Supercomputing Center, providing the high resolution weather and climate component, also sub-seasonal forecasting. Links, which is providing the phenological forecasting. Università di Napoli, providing the phenological model. As companies, we have Elif, leading the crop status service and the platform integration and commercialization. Then we have PricewaterhouseCoopers, a consulting firm, supporting with the commercial strategy to ensure the market reach. And on the end user side, we have the wine producers, Mastro Bernardino, Symington, and Torres, which are intensively involved in the pilots for the validation of the services directly in their cultivars. And what motivated the VitiGEOSS project? We know that the environment is on the priority list of governments, civil society, and policymakers, as there are evident links between the planet, human well-being, and economic growth. As tangible data, we know that Europe is the biggest wine producer in the world. 60% of the wine production comes from Europe, and agriculture is the major economic activity in Southern Europe. 20% of the total jobs in agriculture are related to wine, representing around 3 million jobs in the wine sector. As we are seeing also, agriculture has a very important role in climate change. As experts say, it is responsible for more than 20% of CO2 emissions. And in summary, conventional agriculture is currently facing new challenges, for example, reducing dependence on pesticides, improving biodiversity, and adapting to climate change. And what we want to do with VitiGEOSS is to help to a more sustainable agriculture, in which not only new practices and tools are developed to meet the needs of humans and take care of their health, but also contribute to reduce the negative effects of climate change. And why Earth observation data? Because the wine business and agriculture can be strongly improved with the help of Earth observation systems, because the use of these resources can optimize the efficiency of vineyards thanks to a more accurate mapping, new production indicators, image and time series processing, and more accurate and improved forecasting. With VitiGEOSS, we want to show how satellite data allow the extraction of useful indicators to promote better management and planning of the fields, as well as the optimization of the agricultural practices. The shift towards a more sustainable agriculture through the use of these tools can be key to meet the challenges of traditional agriculture. So the objective of the VitiGEOSS project is to deliver a user-friendly management tool, cloud-based, to advance sustainable viticulture through decision support systems for phenology, irrigation, fertilization, disease, and resource management. For this, we are combining satellite imagery with other data sources, drones images, IoT sensors, remote sensing, in a single entry modular tool that will cover the most important functions of the entire viticultural process. The VitiGEOSS platform will integrate satellite images with sensors in the field in order to improve the resolution and accuracy of satellite information, covering the whole wine process to improve management and optimize resources, and in consequence, being more sustainable. In summary, our goal is to provide a toolbox in a single platform for optimizing vineyard management, capable of offering a set of intelligent services such as weather and climate forecasting, which provides sub-seasonal and seasonal weather forecasts so that growers can make quick decisions, for example, when conditions are expected to damage crops. This Nuria from BCC will talk later. Phenology, which predicts and monitors the annual phenological cycle to plan vineyard management and optimize resources. Then we have also crop management service, in which satellite images monitor crop condition indicators, nitrogen content, and then improves productivity, crop water consumption, and optimize irrigation and crop quality. Then we have disease management service, which will send disease alerts based on symptoms and meteorological characteristics of a geographical area to optimize treatments. Here, Marta will talk later. And finally, sustainability and resource management, which allow a better dynamic planning to choose the optimal time to apply the use of raw materials, also providing sustainability indicators. Here, Josep will talk about this service later. Also, VitiGEOSS is to be demonstrated in 3 real-life scenarios provided by the wineries Mastro Bernardino, Symington, and Torres. They are helping in the design of the platform, the services, and providing data for the calibration of the tools. The validation of the services is done in 3 different areas with 3 different climate conditions, such as Douro in the north of Portugal, the Campania region in Italy, and Juneda in Catalonia, Spain. And going beyond the project commitments, we are trying to expand the validation of the services to other areas in Europe. So if anybody in the audience is a wine grower or has crops available and would be willing to test VitiGEOSS services, you would be very welcomed. And now I hand over to the VitiGEOSS technical team, who will talk in more detail about the intelligence services. I think, Josep, you are the following.
Thank you, Rosa. So next we have Josep Juan, who is a researcher at the Applied Artificial Intelligence Technological Unit at the EURECAT, and he will talk to us about the integration of data sources for greater food sustainability. So Josep, please go ahead.
Okay, so thank you, Andrea, for the introduction. Yeah, good morning, everybody in the room. So yes, I'm going to present a bit an overview of the integration capabilities and so on for greater sustainability. So my speech will be more technical and centered on the integration of data. So the structure of the presentation will be this one. First, brief highlight on the agricultural challenges. Also, then review of the potential and available agricultural data sources, an overview of the data integration capabilities and needs, and finally, we'll see some of the examples that we are applying in the VitiGEOSS services regarding data integration. So let's go. In the agricultural world, we know more or less that at the moment we have 3 main challenges. The first one is that we are a growing population that we have to feed and to provide food for them. As you will see in the graph, there is a growing population for more than 10,000 million people for 2050, which is a very large number. So then the second challenge is also that we have to provide a good, a good environment for farmers to be paid for the effort that they are doing, and also to provide the technologies needed to achieve this challenge, previous one. And finally, we have to deal with 2 previous challenges, also taking care of the environment, being sustainable, applying sustainable practice, and so on. This is a general overview on the challenges of the agriculture nowadays, and it is and they are combined with the digital challenges that we have also in the society. The main one, or the first one, would be the connectivity issues. So although we have 5G connections in some cities nowadays, in the rural area, in some rural areas there are not 3G connections, so it is difficult for them to apply some of the digital technologies that we have currently available. Then the other one is that it is also hard work to highlight the benefits that these digital technologies can provide to them when the people is more used to work on hands than with smartphones and so on. Another big issue is the system interoperability. There are many works and studies and companies and standardization bodies working on this matter, but still there are the lack of integration of many potential digital tools in the world that are struggling the advance of these technologies. Another important part is the farmer skills. Although the new generations are more aware and they are used to work with digital technologies, the older ones not, and even the new ones in their bachelor's, maybe they don't have some precision agriculture degrees and so on. So it is difficult that the highest new technologies or the highest tech solutions could be applied correctly by them. Then the next one is the benefit for ratio. So it is difficult to demonstrate that maybe a farm management information system could help in the short term a farmer, but probably in the long term it's more easy. And finally, the last comment could be the reluctance of sharing data. Although, for example, initiatives like Copernicus and the usage of Sentinel data is promoting several business models. The sharing of data by the end users of these technologies is not as advanced. So let's go to see which are the potential and available data sources in the world that we could integrate for creating any new tool that could save money and also help in the decision making of any farmer. Here are some of the big groups of data. So let's go on each one. So for the statistical data, I've just highlighted some of the bodies that are dealing with this task. The World Bank, Eurostat, and also the FAO has some databases for managing the data at the sticky level of which are the crops more used, the selling prices of some of the goods, and so on. And also Statista, which is a paying service, but also is providing data on this matter. Then if we go to the next group, we have the geospatial data. We can have a static data with locations of buildings, for example, or parcels, earthquakes events, children living in poverty, for example. They are different kind of static data, but also dynamic data like moving vehicles, like tractors and robots, or the capability to monitor the spread of pests and diseases all over the world. So this kind of data combines location data, attribute information to provide meaningful data or the meaning of these locations, and also temporal information that could make the difference between in the same location and the attribute data. And then just providing you some answers or bodies that are working with this is the VitiGEOSS initiative and also the Copernicus one that it's included also. Then we have other private solutions, OpenStreetMaps, the Planet, that is a private constellation of satellites, which is providing more resolute images from satellites, and also Google Maps. Google Maps is maybe the most known tool for this geospatial data and used in many places. If we advance, then we have also the available data source on the national regional data hubs per country and per region. There are initiatives from the governments and the administrations that are sharing data in some way. In this case, for example, I just highlighted two of the initiatives that we have here, at least in Spain, for example, and in particular in Catalonia, we have a network of weather stations, public weather stations, and the administration is providing this data it's open data for anybody who wants to use it. This is a map, for example, of temperatures from yesterday, I think. And also the SIGPAC, that is a tool for managing the parcels and the polygons of each of the fields that are belonging to Spain. And when we could have information about the size, the ID. These are some examples. Then here we have mainly maybe this the greatest solution for integration for information related to farmers. we can have information from the machinery that we have, information from the fields, from the administration and laws, from the field tasks we are doing, from sensors we have in the field, and so on. This is mainly probably the main solution that some of the farmers could use for integrating information. But we have in the market, there are several possibilities and with several capabilities. So yeah, this is just the concept of the farm management information systems. Then we can have another way of sharing data or integrating data that are the business-to-business ecosystems, where we have several companies with targeted technology. For example, irrigation. With irrigation case, we can have companies providing sensors, another companies providing the irrigation systems, and another one providing the recommenders. So their combination of their outputs, digital outputs, could provide a better product probably to the farmer than if they work alone. No? This is another possibility. Also trying to achieve this systems approach proposed by Potter and Hepburn. Okay. Then regarding remote sensing, we can include here the satellite data. But here I just wanted to focus on the other kind of remote sensing data that could use from drones and also for planes. An image of a drone map where I don't know if you will see, but the different binds are identified and also the colors identifying the NDVI value for each one. Then we shouldn't forget the IoT devices service. These are two examples that we are also using in VitiGEOSS. The first one is an in-field camera, which is a fixed camera. This is taking day in reality. And you see the example here. This is the camera installed in the field. You see the guns behind, and also this is an example of the one of the pictures. In fact, this is in Mastroverdino in Italy, and they are stellar. And also the Watic solution, that is a computer or an onboard computer for managing the spraying systems. Okay, and it is controlling the dose, the amount, where it is applied, and so on. And it allows us to generate maps like this, where these are the place where it is treated, and also we can see the differences on some of the sensors. These are some of the examples, the data sources that we could manage in an agricultural project. Okay, so let's see how we can deal with this integration and and maybe which are the main pillars and things to talk about, and also how to avoid data silos and go for an approach that allows us to integrate data in repositories, and we'll see different kind of repositories. So these are the pillars. So let's this is just a list, a summary list. So let's go in deep on each of them. Regarding the origin of data, so for example, in the project we are dealing some of them from handwritten documents, for example, on field observations done directly by the technical staff of our own users, from analogic sensors, digital sensors, relational databases from legacy systems, or from farm management information systems from our partners. A set of files may be stored in a folder or in an email. And what we are trying also to prefer, and it is our main aim in the project, is to use APIs that are a way for easily sharing data between parties, third parties also, and also between us. Then when we go for integration, we have to think and when we have to make decisions with the data that we integrate. I just highlighted the two type of decision making, the ones that require real time and the other ones that could be done on batch. So for real time decision, just make some examples on weed removal based on cameras. There are many machinery now in the market that is working that way. Variable fertilization based on nitrogen concentration. For example, when we are spreading manure from pig farms, there are sensors that are allowing to these tanks or this spreading to be done according to the nitrogen content of the manure. And also it could be also done depending on the variable rate maps of fertilization. Then the autonomous navigation of machinery, like this one the robot that's presenting the picture, that it was done for distributing pheromones in the vineyard, and the variable rate displaying based on the leaf area index, for example, from a leader or from an NDVI map, for example. Then regarding the periodic decision process, that it will not require integrate and process data at real time. We can talk about irrigation that could be done once a day or in a weekly basis, depending on the zone and the technology that it is available. The disease treatments that we are, for example, in the project evaluating daily risk, and we are providing potential treatments at a daily basis, but also we are thinking in seasonal risk assessment, and also the seeding for the cereals that is done once a year or twice, depending. And it is a decision that, depending on the field conditions, it is done, as said, once, and doesn't require the real-time processing. Then another important task also regarding technologies that are available today is that if we want to integrate the data in different ways, these are the two main ways for managing the transforming of the data. The old one would say is the ETL, when the data is mainly structured and came from different structured sources from databases, and it's at the end load into data warehouses. But currently, with the expansion of the big data technologies, we are going to the other approach, the ELT, where the transformation is done before the loading. So the data is loaded in the data lakes, and usually stored in non-SQL databases, and then later on with big data technology, it is transformed and processed. Then another issue is that the data should be comparable. We have a different scale data resolution, for example, from satellite that could give images with pixels, for example, Sentinel till 10 meters per pixel. Nano satellites that could give images at 30 centimeters or even less. Drone images that are going to centimeter images, mobile data from, for example, smartphones and so on, or IoT sensors that are using point data. For example, these different sources can be used for upscaling of the data or downscaling of the data. For example, we are doing using some of data sources for downscaling, for example, the climate services. Then a very big issue on data analytics is the quality of the data. I just presented two examples. These are just examples for weather data that we collected from some of the weather stations belonging to the project. And you could see in the top ones here, some gaps on data, and here some values that are totally out of range. So the gaps, the outliers, the noise on the data, the seasonality should be considered. Then when we integrate data that we don't know a lot, maybe it is without units, so it could be processed wrongly by some of the models with no context, that we don't know the origin, we don't know which sensor has been made, and so on, and also with different frequent acquisition, then it will require some interpolation or extrapolation processes. Then also on data analytics, at least in agriculture, although we know that big data is here, in some cases and many cases, there is not enough data for some of the data analytics problems or models that we want to achieve, want to develop, at least for machine learning problems that we are mostly based on historical records. In some cases, these records are not available, and they are very infrequent situations where we have them. And then when it has, maybe it has not the precision, and it is not homogeneous enough to be translated or extrapolated to other places. So this is also a big issue in this environment. And finally, just for data integration, also to highlight the interoperability and also the semantic interoperability. So there are several formats to change data: CSV, JSON, XML. Probably all of you know all of them, and also protocols and formats again for changing data from FTPs to MQTT for IoT devices. And then it is starting to be a process. There are many initiatives that are trying to structure this data in a common way and creating data models. For example, the Smart Data Models initiative from Figure, or based on Figure technologies, is providing this kind of data, common data models. Then data context of the data, as I said, is based on mostly on ontology representation of the data that are giving context and relations within the concepts or behind the data. And finally, just to highlight some of the typical standards used in this scope that, or at least entities, OGC, are providing standards for like GeoSparkQL or Sensors Things API for IoT devices, NetCDF for grid data. That is one of the standards that we're using for also for climate data, and so on. The map servers. Then ETSI is another standardization body that is we know at least we are working with them for the ontology of SAREF and SAREF for agri and water and so on. Then the OSGeo is providing a standard map server. The shapefile here is one of the formats that we are using to store data from the polygons, also metadata from the fields. And finally, the Inspire initiative from Europe that is also giving some recommendations on how to format all this data. Then, to avoid this, the presence of data silos where data is not shared. This is typical in companies where departments are not sharing data. There are different positive potential solutions. If we have to tackle this integration or managing of data at real time, we can use message brokers and IoT platforms. This is the typical solutions nowadays. But also, if you have to manage of other structured data, we would use data warehouses or data lakes for raw data, as we have been seeing with the ATLs and IoT solutions. So for the message brokers and IoT solutions, just to highlight how a message broker is working. So we have a program that some producers of data are sending data to some specific topics, or topics would be queues of data. And then this data is distributed automatically to some consumers that usually are subscribing to these topics, okay? This is the example of the technology, for example, Mosquito for MQTT formats, Kafka, that is the basis for our IoT platform that we also have at Eureka premises, and that is used for integrating IoT devices in different formats and in different ways, from APIs to MQTT messages or COP or whatever. And the Kafka library or message broker allows us to distribute the data between to processing engines, to storing engines, and also to present directly to the user interfaces when needed, for example. And finally, the Orient Context Broker is one of the context brokers that are providing context information, describing the data where they confirmed and so on. That is also one of the initiatives in the Fireware technologies. Okay. Then finally, just to differentiate the two solutions for storing data warehouse and data lakes, as we have already more or less seen. Data warehouses are more focused on storing structured data, and data lakes is just a pool of data where data is stored in the original raw formats, but could be retrieved by asking some of the key features of this data. So let me finish my presentation with VitiGEOSS examples. 4 of the services we are developing in the project. For the climate forecast, for example, let me say that we are integrating data from Copernicus, from ACMWF CS5, and also from NCEP CFB2. And also this data is downscaled using the ERA-LAM5 observational references and providing better resolution data to our own end users. Then, for example, for the key crop indicators, we are getting data from Sentinel-2, A and B, This is processed and also integrated with grid weather data from GEOSS 5 and also from other thematical data like digital elevation maps. Then it is processed and finally providing key crop indicators like evapotranspiration, biomass, or nitrogen content. For the phenology, in this case, we are integrating also different kinds of data sources. From geospatial data, we are integrating using Sentinel-3 and 2 images. We are integrating data from the weather stations next to the fields that we are monitoring. In this case, the service is integrating to the output from the previous service, the weather and climate prediction service. And also is the integration with an internal repository from data from cameras and drones for the creation of different models for the monitoring and prediction of the phenology in the vineyards. And to finalize, just to make a brief comment on the disease management service. In this service, we are also integrating weather data, but also field observations from our end users to develop two different models, one for downy mildew, another one for powdery mildew, to provide daily risk assessment. Indeed, we also are trying to integrate in this in these models data from the weather and climate forecast, for the phenology monitoring, for the crop indicators and zonal delineation, for creating better recipes on how to manage the treatments, and also integrating the machinery from the Watic solution for sprayers that at the end is allows to us to make predictions or risk assessment using the short-term forecast from weather. And also we are going on the way to provide also disease seasonal risk for the next 3 months, for example, and also better recommendation of the treatments provided by the zonal delineation as example. Okay, and that's all from my side.
Thank you.
Thank you, Joseph. So next, if we don't have any questions, next we have Nuria Perez, who will talk to us about the advanced subseasonal to seasonal climate forecast for adaptation. So Nuria, if you can please share your screen.
Yeah, thank you, Andrea, for the introduction. So I try to share the screen.
And just to mention that Nuria is a researcher at the Barcelona Supercomputing Center.
And good morning, everyone. Today I will be presenting the weather and climate forecast provided by the Barcelona Supercomputing Center to the VitiGEOSS project. This service aims to help the wine producers to anticipate the climate conditions in order to adapt to the climate change. And then I would like to start showing these two nice pictures, just in order to give a little bit of context, and we can consider it that they are good or bad weather in these situations. So for instance, in this image on the right, we can think that it's a nice sunny day, but maybe during these days, the temperatures are higher than normal, and there are these high temperatures can dry the soil and even affect the grapes, right? So this is the concept of the temperatures to be different, let's say different than what we can expect for a given time of the year. What I would like you to remember, if it is hotter than normal, it could be colder than normal or so. So just to also to take a look on the impact that the climate conditions can have on wine production. I have gathered these two pieces of news from the last year. And in the first one, is mentioned that the production, or at least harvest potential was cut by the half because there were these cold spells and heavy rains. And in the second one, which is a new news, an article published by an insurance company. So they mentioned the impact of the global warming to the wine grapes. So what I would like to make you pay attention is that many terms of temporal scales are mentioned, no? Where they go from spells, so a few days, and also they mention decades. So it is the lowest output in decades, so we have a reference of at least 10 years. And also the climate change, no, that is a longer term climate modification. So this helps me to show you, well, the next slide, in which the different forecasts that we could find and how they are classified. So the first forecast is general, very well known, is the weather forecast that aims to anticipate the weather conditions for the following days. But then there is a group of climate predictions in which we can find three types. The first one is the subseasonal forecast, which aims to anticipate the climate conditions for the following weeks. Then there is also the seasonal forecast, which aims to anticipate the climate conditions for the following months and season. And then there is also the decadal forecast, which aims to fill the gap between the seasonal forecast and the climate projection. So as you know, the climate projections are the ones that are used to explore the climate change and the trends and the future impacts for the longer term. So for the wine sector, all these forecasts could be relevant because, for instance, the ones for the longer term will help to select the variety of the grape, but maybe for other forecasts, for shorter time scale could help, for instance, to manage the growing cycle of the wines, of the grapes. So what we are providing in the weather and climate VitiGEOSS forecast, in the weather and climate forecast service, sorry, for the VitiGEOSS project, is the weather forecast for the following 2 days and a half. The subseasonal forecast for the following 4 weeks, and also the seasonal forecast for the following 3 months. And we focus in these 3 regions in which the wine producers participating in the VitiGEOSS project are located. So once a user goes into the VitiGEOSS platform, he or she will need to select the type of forecast, the site, and then one of these variables in the case of the weather forecast. So in this case, these kind of plots in form of a line will be show up, and this corresponds to the 3-hourly temporal evolution of the variable chosen. In this case, is the temperature at 2 meters. It is in degrees Celsius, and below is shown the time of the day. In the case of the subseasonal forecast, the format of this plot is quite different, and this is because of this forecast is a kind of probabilistic forecast. So this means that we are providing here, we cannot provide one single and specific value, if not that we provide the probabilities as climate information. So in this case, we can see that there are, for each week of the forecast, we have at least three bars, that corresponds to the probability of the terciles. This means to be below the normal, in the normal, that is shown in gray, and above the normal conditions. And the user can see what these normal conditions mean. So in this case, for this specific week and this specific location, normal conditions means for the temperature to be between 16.8 degrees and 18.2 degrees Celsius. So for this first week for the forecast that was issued on 19th May 2022, the probability of being above the normal conditions is the highest one, is the 81%. But we are also showing one more bar in this case that corresponds to the extremes. It means the probability of exceeding the 19th percentile in this case. These bars are only shown when this probability is higher than the 40%. It's just in order to simplify the information and let the user to focus on their more relevant information. But as you can see, we are also providing the extreme probabilities to be in the upper extreme or in the lower extreme. So, well, as mentioned here, this forecast is updated in a weekly basis. And if we go to the seasonal forecast, this case, the plot is similar in the format of bars. And this case is showing the forecast for the following 3 months, for May, June, and July, because it was issued on April. And again, it shows the 3 bars to be below or in the normal or above the normal conditions. In this case, there is no any extreme, but it could happen and it will appear here. But here we can see a new information, that is the scale of the forecast. So when we have done an evaluation for each site and each forecast time, and we have compared the forecast in the past against the observations to provide information on to the user or how good has proven in the past to be this forecast is skillful to predict the observed conditions. When there is no skill, a skill is below 0. Then this forecast is shading. So the user doesn't need to pay so much attention. But even the forecast doesn't have a skill, that doesn't mean that the user cannot use climate information, because if there is not a skill in the forecast, it means that the climatology for this specific site and this is able to is worth it and can be used by the user. So these values here, that what means to be in the normal, are also useful for the user. So, well, I have mentioned a few words, skill, percentiles, and so on. So I would like to give you a little bit of more details on how we process this data to get this result, in order to give you a view of why we or what we do to provide this service. So the first thing I would like is to show you this slide again, in which again the temporal scale is shown here below, but we will see also the forecast skill. So if we start with the weather forecast, we see that the skill is excellent at the beginning, but when the forecast time grows, then the weather forecast loses the skill. So how we are able to recover a little of this skill in the seasonal and subseasonal predictions is because we are adding new information to the models that we use. So in this case, apart from the initial conditions, we can use the ocean state or the soil moisture or even climate modes. we add predictability to the system. So you can imagine that we are running this. Well, in this case is the National Center of the Environmental Predictions, the NCEP, that runs the subseasonal forecast, and the seasonal forecast is run by the ECMWF that provides this System 5 forecast. So they have these models that are mathematical representations of the physics and equations, and they run these equations and obtain a few possibilities on how the climate conditions are. And this is done in order to capture the uncertainty that this forecast could have. So well, we take this model data, these observations of the model output, but to get the information, we need to post-process this data. So what we do is to use part of the scientific knowledge, and also we combine them with the user needs. So for the first thing that the user would like to have is higher resolution. So because if you see here, this is the original grid of the seasonal forecast, but we can apply these downscaling methods to improve the resolution of the data. The following thing we do is, based on the scientific knowledge in this case, is to apply a bias adjustment method. Well, just to have the idea, in these maps, you can see that this is the original, on top is the original model output that has very blue colors in this the lowest side of this bar. And when we apply these bias adjustment or calibration methods, we improve the metrics that we use to evaluate the forecast outputs. And then we also need to calculate these probabilities that I have mentioned all the time. So if we remember this, that we have run many times the same model, we have these gray dots, sorry, these yellow dots, and for each of the simulations, this shape could be very different. And what we do is to calculate the areas, the pink, green, or blue areas, and also the areas that are dashed. And we do this to provide later the forecast product. And then finally, we also evaluate the skill of the forecast. So again, we have the observations for the past years. We need to run to get the model outputs for past forecasts. So the institutions tend to run the models also in the past, and we can do a comparison, applying some formulas to be able to provide information on the skill to the users. Another again in the co-development with the users, we need to know how they would like to see this information. So we ask to the users to select one of these options in order to see how it's easier for them to understand the information. So in summary, the weather and climate service that VS is providing to VitiGEOSS, it consists of the weather, the subseasonal and seasonal forecast. It is updated daily and weekly and monthly basis in order to cover these time scales. So thanks a lot, and I don't know if there is any question, please.
Thank you, Nuria. We don't see questions in the chat. Don't be shy, you can ask after each presentation. If we don't have questions, I have one. I would like to know if other variables could be included as part of the services.
So in principle, other variables could be explored because there are some variables that may be easy that may have a skill, but it can depend on the region. So there are some variables that are quite difficult to forecast. I can think maybe in the snow cover or these are quite difficult to predict, but there are others that can be explored. Yes.
Thank you, Marta. I thank you, Nuria.
So next we have Marta Otero, a researcher at Eurecat, who will talk to us about data-driven models for disease prediction.
Thank you very much. Thank you for attending today. I will proceed to summarize the current status of plant pathogen disease models. Okay. Plant pathogens and crop-feeding insects are an integral part of the agroecosystems, which have co-evolved together with crops over millennia. Over this time, plant pathogen selection has occurred naturally, with hosts that are more tolerant of disease being positively selected, and with pathogens constantly adapting to their genome to develop new effective strategies. However, the introduction of new plant varieties lacking the appropriate resistant genes to cope with these pathogens, the introduction of new pathogens into new areas through plant material, and the practice of large extensions of monocultures generate important annual economic losses in terms of production for farmers, who are forced to spend more and more resources on disease management. Thus, the need arises to anticipate these infectious events through data collection and modeling, thereby reducing the production losses and promoting the sustainability of our ecosystem by reducing expenditure on treatments and water. There are two main groups of models in the literature to address this issue. The first group deals with the consequences of host pathogen interactions on crop physiological processes and yield loss, while the second one is related to the study of pest and disease dynamics, which are called Pdms, through which the expansion and maximum growth of the pathogen over time is studied. In this case, the development of the disease in a healthy crop is monitored without any external intervention of biocidal or biostatic compounds, thus reducing the experimental noise and allowing the growth curve of the pathogen in question to be monitored. These models are parameterized and improved over a number of years, taking into account particular varieties and some other climatic conditions obtained from experimental tests. The typical inputs to the Pdms are air temperature, precipitation, relative humidity, and leaf wetness, mainly with daily or hourly resolution, and other features which are all also used are soil temperature, radiation, wind speed, and wind direction. In some other more specialized models, such as those for air transport or soil pathogens. The main challenge facing this models is a progressive shift to a non-stationary climate that adds greater variability in the mean distribution of precipitation and temperature, making the data observed to date insufficient or with low quality to predict the behavior of the system. This scenario forces a continuous retraining of the models with data from several recent years. The VitiGEOSS disease forecasting tool is based on two fundamental subtasks, which are the first one, the early detection of downy and powdery mildew, two of the most relevant diseases in grapevine, which allows anticipating the appearance of diseases and avoiding economic losses. And the second one is the management of these alerts to apply treatments at the right time and dose, minimizing the use of fungicides and water. The project started with a bibliographic compilation just to try to find the most suitable models from widely known and used models through others described in the literature, adapted to each pathogen, and ending with more generalist models applicable to different use cases. The final aim of this service is to predict with higher certainty the different infectious events in order to apply the right treatment at the right time. In short, this service relies on all partners involved in the project for its predictions through field observations made by the end users, the collection of microclimatic data in the field, and the determination of the physiological state of the crop. A huge effort is being done to build a quality database to apply, improve, and mainly develop different models that are capable of generating infection alerts and treatment recommendations thanks to climatological and phenological predictions. Among all the models developed for the early detection of downy mildew, one of the most significant and widely known is the mechanistic oidanic model. This model takes into account the effect of relative humidity, earth average temperature, and precipitation to make predictions. It is based on the criteria that primary infections occur when the average temperature is above 10 degrees, when sprouting exceeds 10 centimeters, and when there is a minimum rainfall, daily rainfall of 10 millimeters. In the graph, it is possible to observe in red the successive potential infective events of this fungus. When, for example, the value reaches 100%, it is interpreted as the incubation period of the zoospores has ended and the disease is evident, considering 70% maturity a high risk. Another downy mildew prediction model is based on the typical sigmoidal growth pattern of microorganisms. When an enough number of growth curves are collected for different varieties and climatic conditions, it is possible to train models showing general trends of microbial growth, allowing to predict the onset of the infective stage and to anticipate its spread by applying treatments. In this graph, it is possible to appreciate how the fungus begins to grow exponentially until it encounters limitations such as the absence of resources or competition for space. In the case of powdery mildew, the demographic growth model stands out, which takes into account the effect of average temperature on the maturation rate of asexual spores produced during the secondary infection. Determining the moment in time when the germination of asexual spores begins facilitates the decision-making in the application of treatments to prevent the disease from becoming chronic. The Bayesian neural network is based on the interdependence between each of the features included in the model, which are called nodes, and their influence on the outcome of disease occurrence. The example diagram shows an interaction between some environmental features, such as temperature, rainfall, wind speed, also with crop varieties, or even the phenological state of the plant. Once the model has been trained and receives new data, it gives a conditional probability of disease risk. For example, if we introduce new features to a trained model, such as, for example, an average temperature of 35 degrees, a rainfall of 2 millimeters, and wind speed of 2 kilometers per hour, it will give us the probabilities of low, medium, and high risk of infection. Finally, in the last 4 years, different works have been published on the use of machine and deep learning algorithms for disease management that have been showing promising results. In the case of VitiGEOSS, several of these models were trained and tested, managing to predict the different levels of disease with an accuracy of higher than 90% during the first year of harvest, and also offering a treatment recommendation aimed at maximizing the effect of the treatment and promoting also water savings. In conclusion, it should be noted that prediction models based on pest and disease dynamics rely on a wide range of approaches to predict infection based on different physiological aspects of the pathogen, that given the increasing evidence of the disappearance of seasonality, those models that seek to make prediction based on the progression of the days of the year, must rely on more recent records or data. That due to the effects of environmental pressure, new strains may emerge that must be constantly monitored and modeled due to possible modification of their optimal growth parameters. And despite these promising results, the models developed in the VitiGEOSS project need more data collected over the successive campaigns to ensure their robustness. And that's all. Thank you very much.
Thank you, Marta. If we don't have, yeah, I think we have questions. Yeah, from Alex and Miguel, thank you for your question. This project is based for grapevines, but might be considered for any other crops, maybe olives?
Well, yes, indeed, they can be also tried in olives. But we are mainly focused on more some kind of different plant species, not such as arborean species, but yes, if these models are again retrained, and mainly we receive data from the other service or another service of the physiological stages and evolution of the crop, yes, it can be extended to, in principle, to any disease in the fields.
Any more questions from the audience? If not, I would like to know if is there any calculation or estimation on how much are the savings, could be the savings in water and fungicides applying this disease forecast?
Well, water savings is more clearly predicted. It will decay at least and a half of the current water applications. The expenditure will decay until the half of actual irrigation. Given the number of treatments to apply, we will must wait for another campaign, I must say, because by now we are seeing that one or two of those treatment receipts can be skipped, but we must confirm that conclusion in the second campaign.
Okay, thank you, Marta.
Thank you.
Thank you, Marta. So next we have Giuseppe Juan, who will discuss towards optimized and sustainable business management. Giuseppe, please go ahead.
Yes, thank you, Andrea. Thank you. Hello, everybody again. Yeah, I will try to make an overview on the possible optimization solutions for sustainable business management in the agriculture and focus it on the VitiGEOSS use cases. Okay, at the end. So my idea. Sorry, let me find. Yeah, okay. My idea is just to first of all make an overview on the potential sustainable KPIs to keep as reference. Then make an overview on the optimization technologies available and processes to take into account if anybody wants to start an optimization project. Then see some of the EURECAD experiences on optimization problems that could be translated in some way to the agricultural sector. And finally, go to the VitiGEOSS optimization use cases that we are implementing in the project. Okay, so let's start. Yeah, sustainable KPIs for sure all of you has as reference Sustainable Development Goals by the United Nations. So this should be given as a reference, but also there are other possibilities like the wine sector, for example, is also developing other initiatives. And in VitiGEOSS, we are also trying to develop some KPIs that could be calculated automatically and trying to facilitate the achievement of these sustainable goals. So in the agricultural sector, the SDGs related are these 6 ones: zero hunger, gender equality, clean water and sanitation, the responsible consumption and production, the live below water, and also the live on the land. These should be the references on all our development, and also we should take into consideration when talking about KPIs all the sub-indicators behind these main ones. Okay. Then as suggested, there's several initiatives that the wine cycle is ongoing, where in the wine cycle are going. The first one to highlight is the International Wineries for Climate Action. This is an action where 2 of our end users are belonging to. Then the Viva Sustainability in the wine Italian sector, that as you can imagine, our Italian partner Masturelli is belonging to. And finally, the B Corp is another sustainability approach that our partner Symington is also has this certification. Then here, I just wanted to show you some of the KPIs that we VitiGEOSS are trying to monitoring in some automatic way. Some of them will be just productivity KPIs, also yield versus yield or yield forecast, control of water usage, but also pesticide usage, and also the related to the food carbon footprint or the CO2 emission control. Okay, and finally some benefits score ratio or the farm labor usage could be useful for the decision making of our end users. So the idea behind this KPI is that we are using 3 different sources for their calculation. For example, Copernicus data for the estimation of the erosion of the different fields. We are using the data logging in the spraying systems for getting data about the treatments and the pesticide usage and the water usage on this, but also the irrigation controllers could be used for monitoring the water use in each field. And finally, we also integrating the data from the different management information systems of our end users that all together we are trying to make an autonomous process to get this data and provide periodically between monthly and annually values at what we call management unit levels. That could be the definition could be a parcel with the same strategy on the management. Okay, so this is how we are implementing it at a VitiGEOSS level. Then, having in mind this, let's go to see to make an overview on the optimization. So, what is an optimization problem? Here, this image is added in the slide is just trying to show you that for an optimization problem, we could have a very large set of solutions, which are represented by these graphs. Then, what an optimization problem would do is just follow this just arrow, starting from a random point, for example, evaluating the different solutions, where the red solutions or we could see that each point on this network or its mesh is a potential solution. Then, for example, starting with what is explained in this image, the algorithm is starting with not good values, but it is exploring the different plane of solutions and trying to find the best one that in this case means that which is the minimum value or the minimum point in the valley of this map. Okay, so this is more or less how an optimization process or algorithm goes, evaluating the different possibilities till it finds the one that is providing the best results, or at least the most good possible, depending on the restrictions. So let's make a recap. So what an optimization problem is just what tries to make an optimization problem is to find the best solution for a defined set of variables and the problem definition, depending on the problem definition, within the considered constraints that we define to them. So the 3 main topics to consider in an optimization problem is that we have to define an objective function, which will be used to calculate how goodness is each of the solutions evaluated. It could be done depending on the cost, on the profits, and on the time, depending on the kind of problem. Then we should define the decision variables, which are the variables that should be considered to evaluate this solution and to create what we call a cost function that could provide this good solution or the best solution. Okay, but also we have to consider if we have to consider some constraints, for example, limited amount of resources, limited amount of time. These kind of things have to be considered and should be specified and modeled in the decision problem. So how we are tackling this kind of process of projects at EURECAT? Initially, it is to be said that we start a very tight or an iterative process of requirements, because any change after all this process could imply to redo everything from scratch. So in order to avoid this, what we are doing is just providing initially an initial document to any party that is wanting to start an optimization project, describing these 3 main topics to address, and also how we will manage during the process. Then we meet with them, and during the meetings we start to get feedback. That this feedback, after all, is again coming back to the document. The partners involved review the document, and in the meeting we agreed what it should be included. And also, again, we have more feedback. We address some more questions, and again until we achieve a completed document when all the requirements for the optimization problem are defined, and allow us to define which is the right technology to address these problems. As you could see in this schema, there are plenty of possible or potential the problems regarding optimizations, and also plenty of technologies that could help us to address some of them. So for this reason, it's also important to understand very in a accurate way the problem, and also to define it properly. Okay, I will not go on deep on the different possibilities, but we can have constraint problems, maybe discrete or continuous problems, and so on. So there are, as you can see here, very different possibilities and technologies. In reality, at the end, when we have selected some of the, which is the right technology to use, these are the three main solutions that we are using for optimization. The Google Aware library, that is mostly used for the more the simpler optimization process that we use. Then we have also experience on using Optaplanner. It's a Java solution for as an IU solver that allows us to define more constrained problems. And finally, this is one of our research lines is using TensorFlow and data agents for the implementation of solutions based on deep learning reinforcement algorithms, okay, or reinforcement learning algorithms that are also providing real-time optimization solutions. Okay. So now let me make a brief summary of some of the three solutions that are coming from projects. Some of them are European that are applying some of these technologies. Okay. The first one we'll see the Sim4 Nexus and Exogenesis projects for the tackling of the Nexus concept. Meshbook is a task segmentation for any mesh software, and Figure for water. It's, we will see an example of optimal control for wastewater treatment plant. Okay. Then going deep a bit, the problem on the Sim4 Nexus and Exogenesis is just the evaluation of policies on the Nexus. The Nexus are composed by mainly these four sectors: water, energy, food, and environment. And in this problem, we are evaluating using the deep reinforcement learning and multi-agent systems the potential impacts of some of the policies in the other sectors. So the results that we are trying to achieve in these projects are to get real-time recommendations on which are the policy effects in the Nexus and also in the other, in any of the sectors, but also try to get optimized selection of policy packages to achieve the sustainable goals or indicators defined as targets. Okay, based, for example, on European regulations, but also could be at regional or defined by some of the stakeholders. The other example is just the Meshbook, is a sequencing and optimal planning tool for scheduling the staff, the machinery, the feedstock when we are in a manufacturing process, and considering also restrictions of the different resources available and all the tasks to be scheduled. In this case, the technology used are meta-heuristics based on local search. And here I'm just presenting a screenshot of the tool that we have taken into consideration. Here are for example, the variables considered for the cost function, and here you can see from the schedule of some of the tasks per each of the workers in the time, and then when we click on it, we can see which are the resources needed and used and so on. To finalize, let me go for the Figure for water project example. When in this case we have a control of a real wastewater treatment plant. In this case, what we want to do is the reduction of nitrous oxide emission and the electricity use for savings of money and also CO2 emissions, for example. while maintaining the effluent quality beyond a threshold defined by the stakeholder. In this case, our technologies used are deep reinforcement learning for the optimal control and digital twins based on deep learning. So the results are we are able to set the O2 set point in a better shape than the current definitions by the experts on the plan. So we are able to save money and water and resources to this company. And let me finish with the 3 use cases that we are implementing in the project regarding the optimization of and sustainable usage of resources. The first one is related to the chute positioning task that is based on just placing the chutes between the wires that are in the vineyards. Then the ground cover management to control the widths between lines and also between the vines, depending on the management strategy on each of the fields. And finally, the harvest planification for getting the grapes from external providers. Let's go in deep. The chute positioning, in this case, what we do, or the problem is facing is the parcel assignation and the scheduling of working groups, because this is a task that it has to be done more or less in 1 month. So it is needed to contract temporary workers, and it has to be done in the right way, taking also consideration on the size of the different vines. Because then if it is done too late, then it costs more time to do the task. So in this case, what we want to do or to achieve the results is to minimize the end date of the task. So it has to be done as soon as possible, because then later on this task, these treatments are probably needed, and also to schedule for each working group the different parcels that they have to work on a daily basis, depending on the stage of each of the parcels. The second use case is based on the ground cover crop management. In this case, there are different strategies for soil cleaning or for cover crop maintaining. Depending on the strategy on each of the field, we are also developing a optimization model that is also useful for flat and also slope vineyards, which the Kpis then regarding the need efforts of each one are very different. And the results should be on a schedule for each of the machines, and also taking into consideration the available workers, the size of the weeds, for example, and considering all this stuff by maximizing the sustainability, so reducing use of chemicals or herbicides, and reducing also the operational cost. This is the second one, and the final one is just to support one of the sellers to organize the grape harvesting for external suppliers that also are far from the seller, so they need some transport logistics indeed. Okay, then here the prioritization of the harvest parcels is considering the Brix degree measurements that is doing the team there. In this case, so what the constraints also, or the objective is to maintain a constant harvest. So each day we want to achieve the same amount of kilograms at the seller, to maintain the same pace for the seller, the same amount of work with an optimal ripeness. So we have to select which of them have to be harvest before than the other, and then we should provide a daily scheduling, but also hourly scheduling for all of the providers to send or to load all these grapes to the seller, and so on. And that's all from my side. If you have any question.
Thank you, Josep. I don't see questions from the audience. They are being very shy today. Then I will ask. I would like to know if these optimization examples would be easily to replicate in other processes.
Yeah, it depends on the level of the optimization that we want to achieve. So and when we start this process of requirements and so on, and it is a very constrained and it's hard, is because we want to achieve the best solution. So we want to take into consideration all the constraints in order to have or to try to achieve the optimal result. So this usually implies that the replication of this process is difficult because it is very tight to the problem that is defined. But if we consider that we can relax some of the constraints and so on, then probably it could be more easily replicated to other sites.
And another question. Should this optimization problem consider also sustainability related variables?
Yes, why not? Yeah, as we said, for example, in the case of the ground cover management, yeah, we are considering, for example, to minimize the usage of herbicides instead of other management strategies like weed removal or weed cutting, for example. Yeah, so it depends on the on which is the objectives. If in the definition of the objective function we define that we want to be more sustainable, yeah, it is no problem if we define the good variables to be addressed in a sustainable way in a problem.
Good, thank you, Josep.
You're welcome.
Thank you, Josep. And now we have a sneak peek into the VitiGEOSS services by Josep and Nuria, and they will showcase the weather and climate, business optimization, and disease management services on the VitiGEOSS platform. So first we'll have Josep.
Are you seeing, yeah, I don't know, are you seeing now the browser?
Yes, we can see the browser.
Yeah, okay. So yeah, again, yeah, the idea now is just to present or make a brief trip or I don't know, a brief overview of what the VitiGEOSS platform has today. This is the landing page of the project. Then when the users can log in, they enter in the platform, and yeah, sorry, this is a real demo. So the real demo effects could happen today. Yeah, this is the what we get when we enter it. Then depending on our role, we will see different kind of parcels. So here in the right side, you will see which are the different parcels that we have. We have an admin role, so we can see the different parcels from all the end users in the project, but this will be limited depending on the role. Let me say that also that, sorry, no, yeah, here we have two main different ways to see data: map data based on the maps, and also the analyzed side when we have the database on graphs or something like this. So starting from one of the examples, for example, yeah, this one from Torres, I will present, for example, the disease on some of the other data that is loaded. Now the platform is loading. Yeah, for example, we have two of the parcels that are belonging to the disease pilot case. When we click on, in fact, from default, we can see the colors here, and also we can select which are the data that we want to show depending on this. Also, the colors will change depending on the scale behind. So when we click on one of the parcels, we can see the data from describing these parcels and also the values of the different key crop indicators. We can also get information about the phenology. These are two output from detection models when these two of the bud break and blooming was detected in that parcels, and also prediction when it was predicted. Then also the users can go can define the real days when this was stated. And in some places, when we have cameras, we can see the images of the field. In this case, we don't have a camera here, but yeah. Then in the sustainability, we have, I don't know if it is an ongoing model, but we can collect the different KPIs of that I presented to you. And in the disease management, sorry, I think that we should, I don't know if it's a problem here now. Let me say, yeah. Okay, this is the output of the disease management. So here you can see differently. This is the Downey assessment and also the powdery assessment, mildew assessment. So here we are presenting the disease risk for the next 3 days according to the weather forecast, and also the past evaluation regarding the weather station data. And here the same for the powdery. Okay, these are some examples. And now I would give the floor to Nuria to explain also the part of the weather, and maybe then I will come back to other services.
Okay, Josep, then shall I share the screen?
If you want, or if not, I can go when you.
Okay. Well, doesn't mind. So, well, as you have said, the user need to select the weather and climate service from the analysis menu, and then also to select a place in the left menu. So the first thing here we can see is the short term or weather forecast is also called, and by default the temperature is the variable first shown. And you can see the 3 hourly temporal evolution for this Friday, Saturday, and half of the Sunday. And then in the menu of the variables, there will appear a few other variables, I don't know, like wind speed, for instance, if you can choose it. Thank you, user. Then the vertical axis change, indicating the variable chosen and the units. So similarly, you can go to this sub-seasonal menu. Okay, thank you. And again, by default, the temperature is shown. And as I have already presented, this is a graph built with bars plot. And well, we see that in this case, all the forecast times have a scale. And for this week, we have 80. Well, it's for next week already. It has been updated for the next week, the week of the 6th to the 12th of June. And the probability to be above normal temperatures will be of the 80%. Okay, thank you, Josep. If you scroll or you move the mouse above the bar, it shows that the probability of the 80% is to exceed the 22 degrees Celsius. It seems that the following weeks, the probability will be to be above the normal. So if we select a different variable, for instance, the precipitation, accumulated precipitation, so it is the probability of the accumulated precipitation for each week. Then in this case, the colors have changed because they give an idea of the dry, you know, we maybe consider the dry colors to be more yellow, and then the wet weeks to be more in blue. And again, you see the mouse is showing the values, what means to be in the normal conditions for each week of the year, and it seems that the following week will be drier than normal, except for the last week of the month that we don't have a good skill. So similar, if we go now to the seasonal forecast, then we change again to the temperature, and in this case, the skill for these 2 first months, there is not enough skill, and it seems that in August the temperatures would be in the normal conditions, showing some skill. So this is more or less all. There are other variables to explore, but to have an idea, I think this is enough. Thank you, Josep, for your help.
Yeah, you're welcome, Nuria. Yeah, let me finish with the business case. So in the business case, this is the initial user interface that we are working for the shoot positioning problem. Okay, so in this case, we can see the different parcels where the project or this service is evaluated. In total, I think that is more than 150 hectares. Then we can scroll, go on the time, okay? And then here there are, for example, in our case, 2 teams from Master Bernardino that should be scheduled here in this schedule, and also the external companies, 3 of, I think, at the moment, external companies expected. Then the user can start a process. I will not start now because it will require some time. But and then the solution of this optimization problem could be placed here, and also when a solution appears, then also here the user or the end user can select if they want to fix some of the schedules, and maybe they want to define by themselves instead of being recommended by the optimizer, which are the schedules for these parcels and which teams and so on. And then it can place again a configuration optimization process, taking into consideration this constraint defined by the user, for example. Then here we have at the moment a text configuration process for defining the configuration. Now it has a JSON format, but it will be awaited soon, where we define all the definition problem on the problem when define the parcels, the number of teams, and so on. So this is, for example, what Master Bernardino would use now, because the supersystem task is starting right now in their field task during this year. And yeah, there are other possibilities and potential features in on the tool but I think that these are the most important ones at the moment. So that's all from my side. So if you have any question, let us know.
That's great. Thank you, Joseph. Let's wait to see if we have any questions. I don't see any questions from the audience right now. Okay, so maybe we can go ahead to the next part, which is an interactive session and questions and answers. There we go. So next we would like to ask the audience to participate in a questionnaire, an interactive questionnaire, and you can go to the website menti.com and insert this code that you see here, or you can scan the QR code. So you can do that on your phone or on your laptop. Let's see if people start joining. I will give you a moment to enter the website. Okay, so here we have the first question. Which of these roles characterize you best? And you can select more than one if that's valid for you. And remember, the code is at the top. So it's 38774034. So we see in the audience some viticulturists, agriculture stakeholder, and researchers, and others interested in the wine sector. You can also use the function to add any questions or any comments. I will give you a moment to respond to this question before we move to the next. So it's menti.com and you use this code. Okay. And let's go to the next question. Here we have, which of the intelligence services presented in this webinar are you familiar with or you have used before? So we have weather forecast, climate forecast, disease management, business and sustainability management. So most of you have used weather and climate forecast before, and some of you have used disease management and business sustainability. I will give you a moment, a few more seconds. Okay, thank you, everyone. And we can move on to the next question, which is how familiar are you with data analytics applications in the agriculture sector and industry? So let us know if you're using data analytics, if you've used it before, if you're not familiar or it's not relevant to your work. So most of you are either using or are familiar with data analytics, which is great. And if you were not familiar, hopefully after this webinar, you will know more about it. Okay, that's great. A few more seconds to respond to this question. Okay, let's go to the next question then. Which are the main challenges in integrating data analytics or the services presented in your work? So let us know which you think are the challenges, either data not available, heterogeneity of the data, lack of technical skills, or any other challenges. And if you have identified any other challenges, feel free to write either in the chat or directly in the Menti in the questions and comments box. Okay, so for most of you, the heterogeneity of the data is a challenge that you see for integrating data analytics. And next we have the lack of technical skills. And again, for those who have selected other challenges, please let us know which challenges you think are most important for you in the Zoom chat or on Menti. That's great. Thank you all for your contributions. And we have another couple of questions left. So next one, would you consider using the VitiGEOSS platform? The platform will be useful for your work, or you would like to test the platform before deciding if it's useful for you, or if you would consider it if there were any additional features. And again, please let us know in the chat which features you think would be interesting for you. And if you would like to test the platform, we would consider any other test sites if it's relevant for us. So please feel free to contact us on the VitiGEOSS.eu website or info@vitigeos.eu. That's great. So most of you think that the platform will be useful for you, or you would like to test the platform. And a few more seconds for more responses. Great, thank you. And then we have a final question, which is an open-ended question. So feel free to write anything you want to reply. So are there any additional services or features that you consider useful to have in the VitiGEOSS platform? Feel free to write any comments, any feedback from what you've seen today in the platform sneak peek. And I'll wait for a few moments to see if we get any comments, or I will leave this open. So feel free to respond after I stop sharing as well. Okay, so someone thinks irrigation forecast would be useful. Crop soil carbon sequestration modeling. Can we have an answer maybe from Marta or Josep or Nuria on this? If we can offer irrigation forecast or crop soil carbon sequestration modeling?
Yeah, if I may, I think that the irrigation forecast in Soil, we are providing some forecasts about water content on soil, it has not been presented today, but yeah, we have some KPIs for modeling it, so it could be done in some way for irrigation forecast, and also yeah, the irrigation is also one of the tasks that we are partially considering in the project. For the carbon soil sequestration, yeah, for sure it could be added. Well, why not? This is a matter of just do it. Yeah, and yeah, the other, yeah, as I said, the nitrogen content, at least on the some maps of nitrogen content on soil and also on plant are one of the 2 features that are the platform has itself, and it are provided by our partner Leaf, for example. Water stress, water, yeah, the irrigation part is something that is also considered in the project, but as yeah, not explained today, but yeah, it is something that maybe we can prepare for the next webinar, focus more on these features maybe.
And maybe, if I may, VitiGEOSS platform is to be extended to other services. It means that we will deliver these services that we have explained today, and others that hasn't been explained, but in the future it can be extended to other services.
That's great. Thank you, Rosa and Josep. Let's see, we don't have any other comments, but as I said, I will leave this open, so please feel free to add anything. Okay, and now do we have any more questions from the audience? Okay, I don't see any questions. So Rosa, please go ahead and share with us some final remarks from this session.
Okay. Well, finally, we conclude the session here. We have talked about the work done in the VitiGEOSS project, contributing to the mitigation of the climate change with new agricultural practices. I hope we have been able to do today to show how data-driven solutions can help to a more sustainable practices for the environment with better agriculture management and optimization of the resources. From Josep, for the data integration, we have seen that the integration of data from different sources enables the generation of novel services and decision-making tools. When talking about data integration, we can have many kinds of data from different sources, domains, precisions, frequencies, etc. And the data integration process should lead also to next investments to get information from missing data silos or get more precise data from current data sources. Also from Josep, related to the optimization service. The main effort to be done when implementing these kind of tools is to correctly define the objectives, to define the constraints and the variables to be taken into consideration. From Nuria, we have learned how the weather and climate services provide the weather forecast for the following 3 days, the subseasonal forecast for the following 4 weeks, and the seasonal forecast for the following 3 months. These climate services include the probabilities of the extreme values and the skill assessment of the forecasts. And from Marta and the disease prediction, it has been explained how, through the use of different models, the VitiGEOSS disease prevention tool detects the key moments of the infection process by the pathogen and recommends treatments on a specific date, which allows savings in fungicides and water, conducting to a more sustainable management of the agroecosystem. Finally, thanks to the panelists for explaining us the progress of your work. And thanks also to the audience for joining us today and for your interest in the VitiGEOSS project. I hope you have enjoyed the session. And if you want to know more about what we do, please contact us through our social media channels or also through our website, which is here, vitigeoss.eu. Thank you very much. Have a nice rest of the day, and we can see you soon. Thank you.
So, thank you, everyone. And just a final remark that you will find the recording of this webinar on the project website and on YouTube. And also we have a short survey that will open after we end this webinar. So please respond that, and also a longer one if you are in viticulture sector. That will be very useful to see some of your insights. So also we will have in the future more webinars. So please register on the website for any news and subscribe. So thank you very much, everyone. And to all the panelists and Rosa for the final remarks. And have a nice day.